Welcome to Rawmachines, your journey to discover the world's most impressive industrial processes. The focus of today's story is Banks Hardwoods, a family-run sawmill specializing in hardwood production in Michigan, USA. What enables a small family company to achieve international reach? And how are those durable hardwood boards produced inside this mill? Join me now to find out. In the United States, hardwood forests stretch across the Appalachia region to the Great Lakes and throughout the Midwest. Unlike softwoods such as pine or cedar, hardwoods come from broadleaf trees like oak, maple, cherry, hickory, and beech. These species grow slowly, have dense grain, and are tough and durable over time. When we look at the tightly packed growth rings, we see the time, climate, and history of the forest where the wood originated. This very quality creates a special reverence for hardwood, a material that is both natural and has the character of heritage. Its contribution to the American economy is significant. Billions of board feet of hardwood are harvested, processed, and exported worldwide every year. Beyond profit, it creates jobs for hundreds of thousands of workers, from forestry and transportation to sawmills and processing plants. But the value of hardwood doesn't stop at the numbers. It is also a story of stewardship and responsibility. And Banks Hardwoods is one of the sawmills continuing that story.
Hey!
Founded in 1985 in the town of White Pigeon, Michigan, Banks Hardwoods began as a small family business driven by a passion for wood. Over time, it has grown into a respected name in the American hardwood industry. What truly sets the company apart is not its size, but its operating philosophy. Quality everything. Quality is present in every step, from sourcing timber and running the mill to training employees and delivering products. For them, no detail is too small. Everything must meet the highest standards. Alongside quality stands a strong commitment to sustainability. The company works exclusively with suppliers who practice selective forest management, ensuring that every tree harvested is balanced by future regeneration. To better illustrate this spirit of resource stewardship, join me now as we step into the vast forests, where Banks Hardwoods begins the very first steps of its harvesting process. Before the first saw blade ever touches a tree, a meticulous preparation process takes place. Foresters walk through the woods, recording every tree species, measuring height and diameter, and determining the age and overall health of the forest. Topographic maps, satellite data, and drone imagery are also used to analyze the entire area. This helps them determine safe transportation routes, avoiding soil erosion or damage to the ecosystem. Everything is calculated thoroughly. Once the plan is finalized, it becomes the guiding principle for the entire team, from the saw operators and machine drivers to the log yard managers. Now, the forest is ready for the next step. The colossal machines roll in, led by the powerful Ponzi harvester. With its sturdy chassis and robust hydraulic system, it can navigate steep slopes and muddy ground while maintaining stability. Its computerized cutting head fully embraces the trunk, clamps down, and in just a few seconds, the tree is neatly and safely felled. The cutting head then rapidly strips the branches, removing every large and small limb. With precise cuts, it divides the trunk into standardized lengths. Each segment is calculated by the machine's software to maximize the high-quality wood and minimize waste. The operator sits inside a sealed cabin, equipped with a display and electronic control system. From there, he operates like a conductor, coordinating speed and precision, ensuring efficiency while maintaining safety for himself and the environment. When the final trunk falls, the forest becomes silent. But this isn't destruction, it's the beginning of a new journey. At the edge of the forest, temporary staging areas, called landing sites, are established. These act as the gateway for the lumber to leave the woods. Each log segment is neatly stacked in rows, sorted by species and size. Then, forwarders load them onto trailers or truck beds. This moment marks a key transition. From a forest resource, the wood begins its life as industrial raw material, ready to enter the processing line. However, transporting the logs is far from simple. The routes out of the forest are often steep, slippery, and even muddy after rain. Drivers must be highly experienced to maintain balance while hauling tens of tons of wood behind them. A small mistake can cause the entire vehicle to slide downhill or the logs to spill, posing a danger to people and damaging property. Therefore, the staging and transportation stage is more than just an intermediary step. It's a critical link that ensures both safety and quality. A log that is handled efficiently and stacked according to standards retains its full value upon reaching the market. The trucks heavy with wood, having navigated mountain roads for hours, finally stop at the gates of the Banks Hardwoods mill. Now, the sorting work begins. Veneer-grade wood, the rarest type with perfect grain, is separated and sold directly to high-end veneer customers. Mid-grade wood, which makes up the largest proportion, enters the mill's main sawing line. Lowest grade wood, which typically has many defects, is sold to manufacturers of pallets or other industrial applications, keeping it out of the primary production line. Each log goes through a detailed evaluation process: diameter, length, straightness, grain, defects, and heartwood. The results are entered into an internal inventory system, acting as a personal file for each log. This allows Banks Hardwoods to tightly control the value, origin, and subsequent processing direction of every piece.
In by contracted log haulers.
From the outdoor yard, the colossal logs are moved by forklift into the sawmill.
The loader then
first
places them
process
onto
they
the
must
transfer deck
undergo
of the
is
bucking station.
debarking. The bark, seemingly harmless, is full of dirt, sand, and pebbles. Just one contact is enough to dull the saw blades, causing inaccurate cuts, or even damaging the entire production line. Therefore, the debarking stage is considered a vital step, protecting the entire manufacturing process that follows. Meanwhile, in another room of the mill, a less visible but equally crucial team is at work: the saw filing department. These are the craftsmen whom Banks Hardwoods considers the silent heart of the entire plant. Standing amidst the smell of hot steel and lubricant, they meticulously inspect every saw blade. Each blade, meters long and weighing tens of kilograms, is removed from the machine to have its teeth sharpened, its tension balanced, and its absolute straightness ensured. This is not just technical work, it is an art. The saw filer must have enough experience to detect the slightest change, a tiny crack, an uneven vibration, or a tooth that has lost its angle. These seemingly small details can determine the efficiency of an entire multi-million-dollar production line. Once the log has been stripped of its bark and the saw blade sharpened to a razor's edge, the stage is set. First, the log passes through a 3D scanner. Sensors and lasers capture its entire shape, curvature, and even internal defects. The computer instantly calculates the optimal cutting pattern, one that produces the most boards at the highest quality with the least waste. Next, the log rolls onto the head saw deck. A massive bandsaw screams through it, and in an instant, the round log is transformed into a square cant. The cant is then sent to the resaw. Here, thinner saw blades come into play, slicing the block into multiple parallel boards of uniform thickness. Thinner blades mean less sawdust and more usable lumber, an ongoing testament to the industry's constant refinement. The slab cuts, the outer portions with bark, aren't wasted. They're sent straight to the chipper, turned into wood chips for the paper or particle board industries. Even the jacket boards, boards with uneven edges, are sent to the edger, where automated saws trim away the wane, producing straight, properly sized lumber. Finally, once the boards have taken shape, they move to the double-end trimmer. Any cracks or defects are cut away, and the boards are trimmed to exact commercial lengths, typically with an extra 2 inches, as required by NHLA standards. The result? From a rough, heavy log comes bright, square, uniform boards. Behind what may seem like a purely mechanical process lies a delicate balance of digital technology, steel machinery, and constant human oversight. And of course, the process doesn't end there. The boards must be inspected and graded, a stage where the experienced eyes of skilled workers remain at the center. Graders stand along the conveyor, their gaze fixed on each board passing by. With years of experience, they can detect warping, cracks, knots, or subtle color variations with just a quick glance. Every observation is recorded and entered into the system, determining the grade of each board. The standard they follow is the NHLA, National Hardwood Lumber Association, grading system, the common language of the North American hardwood industry. Grades such as FAS, Select, Number 1 Common, or Number 2 Common are more than just labels. They are commitments to commercial value and aesthetic quality. A high-grade board might become a premium tabletop or flooring, while lower-grade lumber finds its place in structural or industrial applications. In addition, sensors measure thickness, width, and length to ensure that every board meets the exact technical specifications. If there's any deviation, the software immediately alerts operators to make adjustments or flag the sawing line for review. At this point, each board has been identified: species, grade, and dimensions. All this information is printed on labels, fully reflecting its commercial value, and the boards are ready to leave the mill and enter the living spaces of people. Along the long conveyor, the lumber is pushed toward an area known as the grain chain. The work here may seem simple, but it demands both strength and precision. Each board, depending on its thickness, length, and grade, is sorted by workers into the correct carts or stacks. Even the smallest mistake in sorting can affect an entire shipment, and even the company's reputation. Once the required quantity is reached, the boards are bundled together. Heavy-duty steel straps are tightly secured around each bundle to keep it stable during transport. Forklifts move constantly, lifting the multi-ton bundles onto trucks or into shipping containers. From here, the lumber may head to domestic furniture manufacturers or to seaports for export to Europe and Asia. For Banks Hardwoods, each shipment is more than just commerce. It carries a promise of quality and sustainability. Every board leaving the mill represents a chain of responsibility, from selective forest management and advanced milling technology to skilled craftsmanship and rigorous grading. The journey at Banks Hardwoods has concluded, but a new journey is just beginning. Where will these boards go next, and how are they applied in human life? If you're curious about the answer, join us for our spin-off feature, The Applications of Hardwood in Human Life. This is where the raw nature of the log yields to the finesse of cultural and utilitarian products that accompany us every day. Let's begin. One, lumber in construction and furniture. A bundle of oak lumber leaving Banks Hardwoods might go directly to a furniture manufacturer. There, the boards are dried, planed, and transformed into dining tables, wooden chairs, or high-end kitchen cabinets. The dense, strong grain of the oak, with its characteristic golden brown hue, becomes a highlight in millions of homes. In the construction sector, hardwoods are found in flooring, staircases, and wall paneling. The durability of maple, hickory, and cherry makes them the ideal choice for luxury projects, where aesthetics must be matched with long-term longevity. 2. Lumber in art and musical instruments. Not all boards become furniture. Some of the most selectively chosen pieces, with exceptional grain and good resonance, are sent to instrument workshops. From there, they are transformed into pianos, guitars, or violins. Every note that rings out is an echo from a distant forest, proving that wood doesn't just build homes, it also builds music and culture. Three, lumber in global commerce. Many lumber bundles leave the United States, loaded onto containers for the port. From Michigan, they might travel to Europe, where architects turn them into high-end products. Or they might head to Asia, meeting the market's ever-increasing demand. On every package, the Banks Hardwoods label is the promise: quality everything. Quality in every fiber of the wood, no matter where it goes. The story we have just witnessed is not only the journey of American hardwood, but also the journey of Banks Hardwoods, a small family business in White Pigeon, Michigan, that has grown into a globally respected brand. In a sawmill like Banks Hardwoods, we see the clear fusion of nature, technology, and humanity. Nature provides the valuable raw material, technology delivers precision and efficiency, and humanity, with experienced eyes, skillful hands, and a spirit of responsibility, keeps the entire operation in balance. The future of the American lumber industry is also the future of green materials. As humanity seeks alternatives to steel and concrete, wood, with its inherent ability to store carbon and its proven sustainability, will surely become the foundation for a new era of construction. From the ancient forest to the modern city, from the logs in the mill to the quality products distributed worldwide, the journey of American hardwood is proof that nature, when respected and responsibly harvested, will never be depleted. And thus, every board you touch is more than just wood. It is the culmination of history, technology, and human skill, as well as a promise for a green future for the entire world. Thank you for staying with us until the end of the story. If you love videos like this, please hit the like button, share, and subscribe to the channel so you don't miss any of our exciting upcoming stories. This is Rawmachines, and we'll see you next time. In 1830, Gorham Freeman settled in Greenfield, Nova Scotia, and established a small sawmill. At the time, their simple goal was to supply lumber for the local community's survival and construction needs. Over time, they witnessed major historical upheavals. During the World Wars, Freeman lumber helped build barracks, ships, and military facilities. During economic downturns, the family kept the kiln burning, continued to pay their workers, and maintained employment for the entire community. And amidst the wave of industrialization, they boldly invested in machinery, electrification, and then digitalization, ensuring they weren't left behind. Today, Freeman lumber processes hundreds of thousands of cubic meters of timber annually, primarily spruce, pine, and fir, three iconic species of the Canadian forests. Their products don't just serve Nova Scotia, they cross borders, reaching across the eastern United States from Maine to Florida. But numbers and production volume are only part of the story. The factor that ensures Freeman lumber's endurance is its family spirit. For generations, Freeman family members have directly managed the operations, passing down knowledge and upholding their reputation with their own name. Specifically, Freeman lumber prioritizes sustainable forest resource management. They collaborate with forestry associations and strictly adhere to reforestation laws, ensuring that the trees harvested today are replaced by saplings that will thrive tomorrow. This isn't just an economic obligation. It's a cultural commitment passed down through generations. In over 190 years of existence, Freeman lumber has transitioned from hand axes and steam engines to diesel power, and now to laser scanning lines and artificial intelligence. But the core remains unchanged, transforming the green forest into useful lumber without ever losing respect for the forest itself. And so, the story of the Freeman family opens a door for us. To better understand their values, let's step away from the history books and venture straight into the forest, where the true journey begins. While loggers in the last century had to struggle for hours to fell a single tree, today, a modern harvester is enough to change the entire game. This machine is valued at nearly $1.2 million. Its power lies not just in its massive frame, but in its potent cutting head. The crane arm reaches out, locates, and securely grips the tree trunk marked for harvest. The sharp hydraulic saw blade spins and severs the tree at the base in a matter of seconds. It's a decisive, clean cut, a stark contrast to the ragged saw marks of the last century. The trunk is then held firmly and pulled through steel knives. Branches and foliage are stripped away, falling as lightly as thin straw. Finally, the computer inside the cab precisely measures the length and diameter, automatically bucking the log according to the desired order specifications. Waste is virtually zero. A task that once took a team of loggers hours with axes and saws is now completed in just 60 seconds, with the absolute precision of machinery. After felling and processing the tree on site, the timber is transferred to the forwarder, a transport vehicle valued at around $600,000. Using its hydraulic crane, the forwarder gently lifts each log and places it onto the rear cargo bunk. Its main advantage is that it carries the wood without dragging the logs across the ground, thus protecting the ground cover and keeping the logs clean and straight. When contrasted with images of horse-drawn logging or steam railways from the early 20th century, the difference is truly a technological revolution. Today, logging is no longer a struggle against nature, but a precise, optimized, and safe process. The result is manifold increases in productivity, significantly improved worker safety, and most importantly, the value of every single tree is maximized, cut to precise dimensions with no waste, and ready for the next journey to the sawmill. Once the trees have been felled, delimbed, and bucked, the next, and one of the most critical steps, is transporting the wood out of the forest. That's where the log loaders take over. With their enormous hydraulic arms, they lift multi-ton piles of logs and neatly place them onto the trailers of heavy-duty semi-trucks, often rugged Kenworth, Western Star, or Scania models designed for super-heavy cargo. The drivers then use steel chains and load binders to securely strap down each log load. Every action must be precise, as even a small mistake could cause the logs to shift or roll off the truck on a curve or incline, leading to a catastrophic accident. From the staging area, the heavy-duty trucks leave the forest edge, carrying tons of wood on their backs. Their next journey is the sawmill, where wild nature begins its transformation into products that serve human life. As the 18-wheelers loaded with logs arrive at the gates of Freeman lumber, an entirely different scene unfolds. From the wildness and randomness of the green forest, the wood enters a world of order, rhythm, and technology. Before us is the massive log yard, where thousands of round logs are stacked into piles. This is the mill's material bank, a deep reserve ensuring the production line runs continuously, regardless of weather or fluctuations in the deep forest. From that log yard, each tree trunk is individually lifted and placed onto the infeed deck. More than just simple steel conveyors, this is a sophisticated mechanism where rollers, sweeps, and electronic sensors coordinate smoothly to control the speed, spacing, and travel path of every log. From the infeed deck, the wood proceeds straight to the debarker. In an instant, rotating gears firmly grip and strip away the rough bark. This seemingly simple step is vitally important, as even small amounts of dirt, sand, or debris clinging to the bark are enough to quickly dull the steel blades, potentially causing dangerous cracks and breakage. In the modern lumber industry, the bark is not wasted. It's ground into mulch, then used as biomass fuel for the boiler, or repurposed as landscaping cover in gardens and parks. Once again, the philosophy of no part of the wood is wasted is affirmed. Once the bark is removed, the log moves to the next step, scanning and primary sorting. Here, an entire system of sensors and lasers works simultaneously. They measure length, diameter, curvature, and even identify surface defects. In the past, master sawyers could simply glance at a log and estimate the best way to cut it, the art of the eye passed down through generations. But today, optimization algorithms take over that role instead of intuition. The computer processes the data in an instant, then provides the solution, which group this log should enter, and which cutting pattern will yield the highest value. The result? Each log is diverted into different bins. Straight logs, curved logs, large logs, small logs. From here, they will sequentially proceed to the most appropriate sawing stages. The first step is passing through the head rig, combined with the chipping canter. The laser scanning system checks the log's shape once more. The computer then rotates the log to the optimal angle, ensuring that every cut maximizes the usable timber. The chipping heads begin their work, squaring up the log by removing the irregular outer sections to form a prismatic block called a cant. This process happens at breakneck speed, creating perfectly flat surfaces. The squared cant faces the true mechanical heart of the mill, the twin band saws. This system operates with over 2,000 HP, pushing the timber block through thin, razor-sharp bandsaw blades. This thinness minimizes the amount of sawdust generated, thereby reducing the material wasted due to the saw kerf. After being sawn into rough boards, a new challenge arises: flow management. Thousands of boards are created every hour, piling up chaotically. The unscrambler and secondary singulation system must work instantly to separate them and line them up into a single file. Every board must enter the line independently in preparation for the next scanning and processing steps. After leaving the twin band saws, the boards are shaped but still rough, with uneven edges, remaining knots or other defects. To become standardized commercial products, they must go through a refinement process, where artificial intelligence and modern sensors replace the eye of the traditional sawyer. On the high-speed conveyor, each board passes through the full vision scanner system. Multiple cameras and lasers simultaneously scan every fiber of the wood, recording the grain, knots, curvature, and cracks with millimeter-level accuracy. This data is immediately processed by AI software, which then determines the optimal solution, removing the defective sections while retaining the highest possible value. The decision is no longer based on subjective experience, but is calculated from thousands of parameters. The board, after being trimmed and edged, becomes neat and square, with all defects removed. This maximizes its economic value. A single tree can yield more standardized boards and less scrap material. From trimming, the boards move to the bin sorter. This colossal machine has over 100 bins, with each one designated for a specific length, size, or grade. When a bin is full, a mechanical mechanism opens the bottom, dropping the entire stack of boards onto the chain conveyor below, ready for the stacking process. The boards are perfectly aligned, and then thin wood strips called kiln sticks, or stackers, are automatically placed between each layer of boards. This is a small but extremely crucial detail. These sticks create space for air to circulate, ensuring that heat and moisture are distributed evenly throughout the lumber stack. This geometric precision is the foundation for the wood's final stability. After stacking, the lumber is moved into the kiln dryers, massive drying chambers sealed tight like colossal steel boxes. Inside, the temperature and humidity are strictly controlled by computer. Each batch of lumber can last several days, with a slow drying process to ensure the moisture content is reduced to the ideal level, around 10%. The balanced state that keeps the wood stable in all usage environments. When they exit the kiln, the lumber pieces are no longer the living body of the green forest, but stable industrial material, free from shrinkage, cracks, or warping. But the journey doesn't end there. At Freeman Lumber, there is an even higher standard: appearance-grade lumber, products that are not only durable, but also beautiful and refined, meeting the strict criteria for direct display on the shelves of major retailers, where aesthetics and precision are paramount. The process begins in the feeding area. Bundles of lumber are brought in by forklifts, and then a tilt hoist gently separates each board, moving it onto the conveyor. Here, moisture content is strictly controlled, with the wood dried to about 10% to ensure uniform stability and quality. The next step is the heart of the line, the 8-head Moulder. Amid the resounding noise of steel, each board passes through and is planed smooth on all 4 faces. From rough surfaces, the wood becomes sleek, its grain highlighted, and its edges sharp. From this point, it begins to take the form of a premium commercial product. But simply planning it smooth is not enough. Freeman Lumber also invested in the full vision optimizer system. Industrial cameras meticulously scan every wood fiber and every knot. The AI then analyzes this data to identify the aesthetically superior and the defective sections. If necessary, lower quality wood segments are automatically removed, retaining only the high value portions. After processing, the lumber moves to the trimming stage to be cut to the exact lengths required by retailers: 6 feet, 8 feet, or 12 feet. Following this, the automated stacking system perfectly aligns each board, creating square, uniform bundles with near absolute precision.
An appearance-grade product needs to be carefully and slowly stacked to make sure that we don't damage or mark the product. The remaining boards go to what we call a green chain to be hand stacked. Once a lift is full, it's pulled out to be picked up by a forklift. From there it'll go, be packaged and end tagged.
The final step in the process is specialized packaging. Each bundle of lumber is wrapped in white nylon printed with the Freeman Lumber logo, and the corners are protected with edge protectors, ensuring the product is not only durable but also clean, tidy, and visually appealing.
Presentation is everything, and neatly packaging and covering the lumber in a bag is essential. It also protects the lumber from dust, water, and other debris. Units are barcoded end tagged, and strapped. You'll notice that corner pieces are put in on either side of the tarp to make sure that the lumber doesn't get dented by the strap. Once a lift is packaged, it gets conveyed out to our 18,000 square foot warehouse, where it stays out of the weather until it's loaded onto a truck.
But not all lumber is destined for decorative purposes. The mass construction market demands higher volume and efficiency. That's why we need the planer mill, which serves as the final stop in the entire production chain. The process here begins by removing the kiln sticks, the thin strips used during drying. Instead of being discarded, they are collected, sorted, and reused for subsequent batches of lumber. As the boards enter the line, the high-speed planer immediately starts up. With a processing capacity of up to 2,000 feet per minute, the rough edges and surfaces vanish in just a few seconds, replaced by smooth, uniform boards. Next, the full vision scanner system performs another comprehensive scan. The AI immediately classifies the boards. High-quality lumber is kept whole, while boards with defects are trimmed into smaller, commercially valuable sizes.
Once a lift is full,
each board is then grade stamped, a blue or red ink mark confirming its technical standard, acting like a certification that allows the lumber to go straight into construction projects. This is the common language of the lumber industry. One stamp, one symbol, is enough for an architect or carpenter to know exactly what kind of wood they are holding.
Make sure that the lumber doesn't get dented by the strap. Once a lift is packaged, it gets
the boards are then distributed to the bin sorter system, which has dozens of compartments sorted by size and quality. When a bin is full, the bottom opens, dropping the stack of boards onto the conveyor belt leading to the packaging stage.
Some of our wood
Here,
gets repressed.
high-speed stacking machines operate like massive mechanical
As you can
hands,
see,
rapidly
boards are
aligning,
individually loaded
layering, and compressing the
another
boards
low-speed
into a
Moulder.
square block. Finally,
Moulder
steel straps are
takes
tightened around the bundle,
already
and a
dressed
white
lumber
nylon wrap provides
puts a
protection
pattern on
against dust and moisture. The
Today
final
we're
products are
doing edge and
robust,
center.
tidy
Same
bundles of
product
lumber,
that you'd see
ready
used
for
for
direct loading
beadboard
onto
at home.
trucks or long-term storage.
Today we're running at about 120 feet per minute. Slow and steady wins the race. Each board is individually inspected to make sure that the dressing quality and the pattern is put on the board correctly before it's stacked into an individual unit. Not only is this lumber shipped locally, our big box program actually supplies up to 160 stores. As you can see, once the product is complete, it's loaded on a flatbed truck and tarped and sent to the final customer.
From Nova Scotia, these bundles travel by truck and ship, crossing thousands of miles to the eastern coastal states. In construction supply stores and carpentry workshops, Freeman lumber starts a new journey, becoming the foundations, door frames, and roofs for millions of families. The planer mill acts like a central station, where massive production volumes are refined and distributed. Here, the contrast is clear, from raw logs scattered in the forest to uniform, perfectly packaged industrial products, ready to join the global commercial flow. And so, we have completed a long journey, and Freeman Lumber stands as a unique witness to that journey. Starting as a family sawmill born from the pioneering spirit of its founders, they have endured for nearly 200 years, overcoming wars, crises, and industrialization. To this day, Freeman Lumber still keeps that flame alive, continuing to transform the green forest into products that serve human life. More importantly, Freeman Lumber doesn't just produce lumber, they uphold a philosophy of life. No part of the wood is wasted, and the next generation will not lose their forest. Every tree harvested means several new saplings are planted. Every bundle of lumber leaving the mill is proof of the balance between utilization and conservation, between the past and the future. Wood, seemingly a simple material, is actually the red thread connecting humanity to nature, connecting humble workers to the homes, schools, and bridges of millions of families. In every fiber of wood, we see the sweat, the knowledge, and the pride of countless generations. And thus, the story of Freeman Lumber is more than just the story of a mill. It is the story of a timeless industry, proving that if humanity respects nature, we can simultaneously harvest, regenerate, and build a sustainable future together. The journey from forest to lumber, which seems to have concluded, is actually continuing day by day. In the resounding noise of the saws, in the steam of the kilns, and in the saplings stretching skyward across the Nova Scotian forests. Thank you for staying with us until the end of the story. If you found it interesting, please hit the like button, share, and subscribe to the channel to keep following our new journeys. This is Rawmachines, and we'll see you next time. Welcome to Rawmachines, your journey to discover the world's most impressive industrial processes. The focus of today's story is Banks Hardwoods, a family-run sawmill specializing in hardwood production in Michigan, USA. What enables a small family company to achieve international reach? And how are those durable hardwood boards produced inside this mill? Join me now to find out. In the United States, hardwood forests stretch across the Appalachia region to the Great Lakes and throughout the Midwest. Unlike softwoods such as pine or cedar, hardwoods come from broadleaf trees like oak, maple, cherry, hickory, and beech. These species grow slowly, have dense grain, and are tough and durable over time. When we look at the tightly packed growth rings, we see the time, climate, and history of the forest where the wood originated. This very quality creates a special reverence for hardwood, a material that is both natural and has the character of heritage. Its contribution to the American economy is significant. Billions of board feet of hardwood are harvested, processed, and exported worldwide every year. Beyond profit, It creates jobs for hundreds of thousands of workers, from forestry and transportation to sawmills and processing plants. But the value of hardwood doesn't stop at the numbers. It is also a story of stewardship and responsibility. And Banks Hardwoods is one of the sawmills continuing that story.
Hey!